There is this system of 3 types of OEE losses, which I really don't like. So let's discuss which categories I do find useful. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. In this video, it will be about OEE, that is overall equipment effectiveness, a way to measure how effective your lines are working, how much time you are spending to actually make the correct product, and how much time you are wasting on all kinds of different categories of waste. Now, there is this 3 types of waste system that we'll come to in a minute, and as I already spoiled in the beginning of the video, I really don't like it, but we will go through it and I'll let you sort of come along on a journey to see how to measure OEE so that the value that you get out of it is also balanced with the effort you put into it. Because that is also one of the things many people forget to mention. Really splitting up your data into these categories often is a lot of work, because machines cannot generally tell specifically which category it is. The operator often has to do this. So the finer you make your categories, the more work you're usually putting into the hands of your operator. So those things, let's go over them and let's see what the value of these categories is and what they are in the first place. Now, I think it is good to first take the very broadest category that we have for OEE measurement. And that is good and waste. So basically, this is your OEE percentage. Now, in this bar we have a very low percentage, but that's because I just want to have some space for all of the categories. Hopefully your OEE is somewhere between 50 and 85 or so. If it's under 50, it's possible, and definitely in practice this happens, but you've got a really low performing line. If it's over 85, I think you're leaving out categories, but that's it. And this is waste, so good and waste. This split, so just knowing the OEE, I think might be more effective use of your resources and time than the most popular way to measure OEE. Because the other thing is to split up these wastes into a couple of categories. So what it splits it up into is your quality wastes, your performance wastes, and your ability wastes. But also, if you take this amount of time divided by the total time, so when we, for instance, check good divided by total, we get the OEE. If we, this is also called effective time a lot. That's actually the better term for it, so effective time. If we take the quality, so the non-quality basically, and the good product, and we divide it by the total time, we get the performance level. If we also include all the performance losses, so this is, short stops and then speed basically, so performance up until here is just how many strokes is it making when it's running. You divide that by the total time, you get its availability, because basically if you just check when is it making a stroke, you are measuring when is the machine running in the first place. And the availability losses, they are a huge category, because they are, the factory is closed, which is usually completely left out of this type of OEE registration, but also do we have some plant maintenance, or are we cleaning, and even do we have a breakdown. So everything that just completely stops the line so that the operator cannot operate that line, that is all an availability loss. As soon as the operator is actually working with the line and they're producing product, maybe fast, maybe slow, maybe good, maybe defect, but that is all in that part where the machine is available. Now, what this does is, because availability takes everything from planned stops and cleaning up until the non-planned breakdowns that you get. This is a huge category, and it's no use for planning, it's no use for knowing how effective your line is. It is maybe useful to see how well the machine is performing per hour, so to say. And you could call this the operator's effectiveness. Right? For that, it can be useful, although also a bit dangerous if you do not know the rest of the story. And let's face it, operators can definitely also cause breakdowns. Not all breakdowns are due to poor maintenance or a bad line. If you run the line in a bad way, you can just jam it, which will be registered as an availability loss in this system. I don't really like it, although I do understand why people use it in lieu of the system that I would propose, because actually to do that I'm gonna have to well, I'm gonna have to write pretty small because I want a whole bunch of categories, and that is a lot of work. But okay, let's get those categories on the board, shall we? So you see there is a whole list of loss categories, but all of them are useful. Now let's also link them a bit because they do have the same basic categories, so they do fall into those categories, and we can link them a bit. So all of this is in availability. Performance, I break up into short stops and speed losses. You don't need to do this, but those two split it out in an even finer way. Quality is exactly the same, the good stuff, and effective, that's what I told you, right? Effective time is basically what they call the good production. Now, why do we split it up into those categories? And why doesn't this system do it? It's a lot of work. That is the main reason not to do it. And if your organization doesn't really know how to work with these categories, you're going to get bad data, and that is not going to help you. But let's also check a bit, why would that be useful? And maybe first let's go quickly through the categories, because the names sometimes they differ a bit, right? So when the line or the factory is closed, that means nobody's working there, it's just not planned in. This is generally when you're closed in the weekends or at night, stuff like that. But it can be with individual lines that are just completely planned out. No personnel is taken onto the staffing schedule for that line at all. So maybe in a factory that runs 24/7, you have one line for specialty products that just runs 5 shifts a week or so. So the rest of the time it's closed. Now, overcapacity, the difference here is we do have the people. So basically the line is ready, but we planned no production. And this happens quite a bit, especially when you are in 24/7 type of shift work. And it's not about, we cannot close in the weekend. We just have a couple hours every day that we don't fully fill this line. If it's been running wonderfully, we just don't have production for it. But we don't send the people home because our contracts don't allow it. This is common practice for many companies, that you just plan out a line. But the people are there. Also, there is no maintenance or setup or any of those things, right? So nobody's touching the line, but if the planning department says, oh, we need that line, it can be up in a couple minutes. Then planned maintenance. So this is not all maintenance, it's not like breakdowns, but planned maintenance. The bigger setups, here we are talking about cleaning, initial setup, really a product change that requires a lot of time. Most importantly, again, planned. So maintenance and setup are planned downtimes. Supply issues, supply failure. This is a lack of something from outside the line. It can be that you have no operators or no electricity that directly influences the line, but it also really refers to the downstream machine cannot handle product, so we now have to stop. Or we don't have the upstream machines working, we don't have the product to work on. So the machine is basically ready, but you don't have either the input material or people or electricity or something like that, or you are not allowed to push out product yet. These are generally not planned, because if this would be planned, they would close the line and put it into overcapacity. Then a quicker changeover. This one, by the way, is not used a lot. I've only worked in one company where I saw the splitting between planned setup work and non-planned. The small setups, the changeovers, changing a foil roll, or maybe a small product shift or a label change, things like that, that generally take a couple minutes. In big oven stuff, they might take a few hours, but as soon as this type of loss takes half an hour or more, generally organizations plan it and it becomes just a setup. But these are those quick things that you need to do, but you don't really plan the time. And then breakdowns. Now, about those two, you could say that they need to be in the other order. I'll get to that in a bit, but these are not very critical. The breakdowns are longer, unplanned stops of the line due to the line not being able to work. And why do I put it in that way? It's because it is not only technical. So this does not mean that the line, the equipment machinery part has to have broken down per se. It can also be a paper jam in a copier. So basically the copier is fine, but you need to remove stuff and it just takes quite a bit of time. Generally, the difference between a breakdown and a short stop is defined by a few criterions. And the most used is time. So many organizations will say anything over 5 minutes or 2 minutes or 10 minutes, those are a bit the flavors you generally get, is a breakdown. Anything under our number is a short stop. A second criterion that you see a lot is when the operator can solve it by themselves, it's still a short stop. When they need to get in a technician, mechanic, then it's a breakdown. So it depends a bit on how you put this into effect. And if you make a combo like anything under 10 minutes not requiring additional help stays a short stop. Anything over 10 minutes is always in one of the upper categories. Or if you need to call in help, so if after seeing the error pop up on your machine, you immediately know, oh, that is not good. I'm going to call my technician. Even if they fix it within 5 minutes, it becomes a breakdown. In practice, I have not yet seen that the difference of do we need to add parts, or because that's the third one, or call in a technician makes the difference. Because if you do that, almost always you're already over your 5 or 10 minutes, whatever you put in your system. So generally it's time, but bigger breakdowns that really stop the line. Short stops are those annoying things that the operator can fix. They may cost a couple minutes even, or just 20-30 seconds. But you generally get quite a number of them. And if you add all of them up, they account for quite a bit of time, generally with machines. Then speed losses, again the difference, short stop, the machine really stops. Speed losses are those small, basically, if you do it very pure, the machine doesn't even really stop. It just moves slower than it could do. So then it's passport speed, it's nameplate capacity. So if the machine should be producing a widget every 30 seconds, but you're only getting a couple per 5 minutes, and in the end you see that on average they're coming out every 40 seconds, you've got the 10-second speed loss in every cycle. So that is the speed loss, assuming that it is not a short stop. Now those two, if you are registering manually, are often lobbed together into performance. Although what you could also do is, if the machine has a speed setting, you register the set speed. That is your loss. You've got this 50 strokes a minute machine, you put it to 40, that's immediately a 20% speed loss. And if you then actually are moving very nicely, it's almost no short stops, for instance. Anyway, moving on, quality, exactly the same as here. This is a difficult category, which, by the way, is one of the reasons why I don't like this split. But quality is any product that comes off the line, basically after your counter, that is not good. Any product that the line makes, but that does not reach your warehouse, is a quality problem. It's difficult to measure. So the best way generally to do this is to have sort of a double counter on the line. So you have your heartbeat part of the machine, and especially if that's a bit in the middle of the machine, there you have your counter for the speed and all these things. But then completely at the end of the line, after maybe a couple of checks, maybe you have a check weigher tossing out some products, or you have visual control or things like that. So at the end of the line, sort of at the packing assembling stage, you have another counter, and that one checks if every product that came out of the heartbeat also made it till the end of the line. Then you have an easy way to check for quality. If your sort of heartbeat, but at least your counter, is already at the end of the line, and your quality problems will only pop up a day later or so, or in another department, it's difficult. It's not impossible, you can definitely do it, but then you are getting into very difficult analysis and putting it into your OEE, because you want this number to just be active at the line immediately and in your daily meetings and stuff like that. So, difficult one. And of course the effective time, same as over here. Now, because of that, what you see is that this effective part is the same quality for a lot of organizations is so difficult to measure that you don't really do it. Performance is how fast the line runs. This one is actually useful, and then that all becomes availability. But when we go for what do we need in the organization, and need, well, that is a big word, but there are all kinds of different uses for the different levels. That's why they are built up in a specific order as well. For instance, here, between closed and overcapacity, we have a link with labor. Because any time that the line is closed, we are not spending labor. Any of these categories, we are spending labor. So from this till this, all that time multiplied by how many operators are running that line are also direct labor losses. So we've got direct labor spend here. Then maintenance, because you really plan it out, is something else than setup. Generally, it depends a bit on your organization, but if you have sort of a process type of industry, you've got these maintenance weeks per year, stuff like that. So maintenance is clustered. It's not even a weekly thing. Setup is generally a daily or at least a weekly thing. So if you want to compare week to week, you don't want maintenance to be added in. So that's how this is a useful split, especially for comparison. But more important, this is planned, this is planned. So here, all of these are unplanned, which means that this percentage, so let's get back to what was OEE again. OEE is effective divided by something, right? And this becomes a percentage. Now, without going into all of the naming stuff, there is I think it's a mainly French system, but still there is also an internationally used system with TEEP and TRP, and that sort of splits what you take into total time. The official definition is this small square here, you divide it by the whole bar. But when we are in the planning department, we take this as a much more useful thing for us. Because what we do is these we all plan in, so those are just blocks in the planning, and then the effective divided by up until supply failure, so all of the unplanned plus all of the unplanned losses plus the effective time, effective divided by that becomes a percentage that we put on the line speed when we are talking OEE of a line in planning. Think about that. When your planning software, and I think even relatively poor planning software like SAP, really not planning software, many planning software packages, they have lines with a speed, And you can say, well, okay, this line should be able to do 50 a minute. And then it also has an OEE percentage. Do not take the total OEE. Because if you are planning weekends off, if you are planning to stop the line, some maintenance, the bigger cleaning stuff is all blocks in your planning. If you do that, then the time that you actually plan in the line for production, it will be this effective. So if that one is 50% with all the closed time included, but this is quite a big part of your downtime, maybe the effective to planned ratio is already 80. So you put an 80% of the 50 packages per minute that our example line had into your planning. When we go further down, and here you see why it is useful, performance, or here, what is what we want to do on a daily basis? So this is what I would like to know hourly. This maybe without the supply issues. Now, why do I make this distinction? You see, the performance and quality losses, they are all on a very short time scale. So if you are checking how well is my line doing on a line board with an hourly rhythm, or you check at least a couple of times per shift, so every 1 or 2 hours you check how you're doing, a breakdown may have just completely ruined your hour, or there was a changeover that add a whole part. You have not been producing. So the production number should reflect that, right? But if you are checking how well your line has been running, if you, for instance, had a 20-minute changeover in the last hour, you also want to know the other 40 minutes. How was I performing? So on those 40 minutes, you want to know my performance and quality numbers. So that's why on that hourly, on that line board, you want to keep them in. But daily, if I'm the production manager, so that's a more of a daily scope, breakdowns, changeovers, those are really important. Supply failure, it depends a bit on how much that is in my zone of control, if that makes sense. So the breakdowns and changeovers, definitely something that as a production we have to take care of it, we influence it. We can not always prevent a breakdown, but we can act on it to make it faster, less frequent, put it into planned maintenance. We can reduce the number of changeovers. We've got a lot of tools for that, you know that. The supply failures, it depends a bit on what type of supply failures. It depends also a bit on the scope of a production manager. So if you have factory director, production manager, probably you put it in. If you have factory director, operations manager, production manager, so you have somebody else doing all kinds of supply chain stuff, and maybe the personnel planning is not in the hands of the production manager or the team leaders, you keep it out. Depends a bit. Very deep discussion. The main thing is, do you see how these categories, they shape the way we report or use OEE numbers? And there is not per se one right way for this. But these categories, they are made so that you can shift your equipment effectiveness, calculations, loss analyses, predictions to different levels in the organization. You can imagine that on a corporate scale, everything is important because we are, for instance, talking about investing in new big lines. So let's say we've got a couple of factories even, right? Got a corporation with 20 factories that can do more or less the same type of production. If 2 of them, or maybe all of them, are not working in the weekends, it might be a lot cheaper to close a few plants and let them all work in the weekends. Or if we are thinking of building a new plant because we've reached our capacity, but we've also got a couple of plants in our network that still have a lot of closed time, that is gonna, if we can tap into that factory closed, a line closed time of those plants, it'll save us a lot of investment. So on a corporate level, super important. Here we have the split, labor or not labor. That's why you want to make that split, because this ties into P&L. You want maintenance and setup to be separated. You also want overcapacity and maintenance to be separated, because this is time that your line is not available. It is really a cost, and you want to compare it with your breakdowns, and you want to benchmark it. So this is really for the maintenance department, that one, and that one is interesting for your maintenance department. Then planners, if you planned and your unplanned stops, you see that the different levels really use your complete OEE system in a different way. I also would not suggest that you put all of these categories in front of your operators every time. For the operators, yes, good system. Availability, performance, quality. In fact, I would even take out a couple of these and have the availability start from setup or even from the unplanned stuff. It depends a bit on how you want to communicate with them and how much influence they have on setups, because quite often the speed of cleaning, the quality and the speed of cleaning is in part determined by the operator. So see, another line, and on a different time scale or on a different strategic scale, we're going to use different numbers. That is why we have all of these categories in. That is also why if you just have these, you can only basically communicate on a daily level. This is useful for your daily meeting and nothing else. And frankly, it's not even really useful for your daily meeting, because I want to stop it over there already. So that's why you will see these TEEP, which is everything, and then TRP, I think, ignores these, or maybe even maintenance. I don't know them by heart, which of those acronyms covers exactly which one, and then in companies that do use them, they will use OEE starting from there somewhere. They're basically doing the same, but making it more complicated. Have all your categories, communicate where needed, what is needed, so that you have good discussion material, so that you make information for decisions out of your data. That's why you have them. Then, of course, a word on, how do you actually register this? The good thing about these is that they are so big that they hardly require additional registration. But for any registration that you do manually, especially on the line, the operator is registering when the line has stopped, putting in a reason. Many people like to break this down further, so they break down the breakdown into which line, which cause, what piece of the equipment in which part of the line, and you, for instance, put a complete maintenance breakdown of your line into the reason tree for OEE registration. Oh, please don't. That is, you're going to get very crappy information, very crappy data, because operators will just not do it. But also that requires a lot of time. The same with the changeover. You really want to know which changeovers they were, maybe. But if you are thinking of doing sort of this, but then with a whole bunch of categories, just take these. Honestly, on an input basis and also on a reporting basis, I hardly ever care about what type of close time it was, what type of overcapacity, what type of maintenance. Maybe in the setup, maybe I want to differentiate between a cleaning or a big product change or the startup of a line, maybe. In fact, you can, when this becomes interesting, often you are also working with lines who can get this out of the PLC. So here, go with what your equipment can already tell you, because you're running a certain program to clean the line. Can the PLC pick it up automatically? Stuff like that. With supply failure, you probably want to split it out into a couple factors. That is also because this should not happen too often. And these broad strokes, really broad strokes, there should not be more than 5 or so subcategories here. Short stops, don't even register them, don't explain why they are. Speed loss, don't explain. Quality loss, generally don't explain. So make sure that these are very simple categories, and then you can have all of them in an easier system than many of the implementations I saw of this. So there you have it. Why I actually like the overall OEE of effective divided by total more than these three categories. Why I think you really want to have all of them. You could, if you want to, combine some when you know what you are doing and when that suits your organization. But in general, get a good registration system. In the future, you will want to have all of this, and hopefully you will thank me for that later. If you already like the video right now, don't forget to hit that like button. Also, put your comments, questions, things you want to share about OEE in the comments below. I really love reading from you. And for now, I wish you the best of luck with your equipment effectiveness. And as always, enjoy the continuous improvement journey.